Hello students. So today we are going to start with a new lesson, that is complex numbers and quadratic equations. Now what do you mean by a complex number? We have seen real numbers and integers, rational numbers. Okay. Complex numbers are a different set of numbers, okay, which does not belong to real numbers. So whenever you have a quadratic equation, say ax square plus bx plus c equal to 0. Now there are many ways to solve this equation, that is factorization method or quadratic formula method. Now when we use quadratic formula method, we find discriminant, right? So d is what? B square minus 4ac. This we have seen in standard 10th. Okay. Now when the discriminant value is equal to 0, we have equal roots, equal real roots, right? When it is greater than 0, we have two distinct real roots. And for less than 0, when d is less than 0, we write as no real roots. That is, we get something like this, root of some negative number. Okay. So this number is our complex number. So this type of numbers falls into the category of complex numbers. Okay. So this complex numbers and quadratic equations are linked with each other. So we'll write it as that root of -1 is nothing but I, and I we call it as imaginary number. Okay. Okay. I is equal to root of -1. It is also called as iota. Okay. So this is a part of complex number. Okay. So first we'll learn about this I. Okay. Later on we can define what is a complex number. Okay. So basically a complex number is of the form z is equal to a plus ib. That is, this I imaginary number becomes the part of complex number. Okay. So let's start with our I. So I is root of -1. I square will be what? I into I, right? Which is root of -1 into root of -1. So root of -1 square. So we'll get answer as -1. So I square we can write it as -1. Okay. What about I cube? I cube is I square into I. I square value is -1 and I is this. So minus I. So I cube is minus I. Okay. So then further I raised to 4. You can write it as I square into I square. I square is -1. So this is 1. Okay. So this way you can solve any number which is given, means power of I, you can solve and find the answer. Okay. So suppose you have a number, say I raised to 30. Okay. So I raised to 13, you have to convert it into something, 13 you have to convert it into a even number. So even number you can write it as I raised to 12 plus 1. Okay. So this is I raised to 12 into I raised to 1. I raised to 12 we can write it as 2 raised to 2 into 6. Right. What is the value of I square? It is minus 1 raised to 6. And we know that a negative number, when it is raised to an even number, we'll get it as positive. So the final answer is I. So trick here is you have to convert this power into some addition of even numbers. Okay. So that you can write it in terms of I square, where you can substitute this. Next is 1 upon I. 1 upon I, you can write it as I raised to minus 1. Okay. Or you can rationalize this. That is 1 upon I into I into I. Okay. So this becomes I upon I square. I square is minus 1. So the final answer is minus I. Okay. What about 1 upon I raised to 5? This you can write it as I raised to 4 into I raised to 1. I raised to 4 you can write it as I square raised to square. So minus 1 raised to square. Okay. So this is 1 upon I. 1 upon I is what? I. Okay. Minus I. Sorry. Next. I raised to 347. Okay. So now you have to write this as I raised to 346 plus 1. Okay. 346 you have to divide by 2. So this is 173. So I square raised to 173 into I. I square is minus 1. This is odd number. Odd means this will be minus. So final answer is minus I. Okay. I raised to minus 1003. Okay. This we can write it as 1 upon I raised to 1003. Now you have to split it. 2 into I. Okay. This you have to divide by 501. So minus 1 raised to 501 into I. So this is again an odd number. So minus 1 upon minus I. Okay. 1 upon I is what? This minus I'll keep outside. 1 upon I is minus I. So this is plus I. Okay. Plus 1 upon. Okay. So you have to simplify this. This you can write 110 into I plus 1 upon I raised to 110 into I. So 110 divided by 2 you have to do, 55. So I raised to I square raised to 55 into I plus 1 upon I square raised to 55 into I. I square is minus 1 raised to some odd number minus. So this is minus I, and this is also 1 upon minus I. So my 1 upon minus I is minus of minus I. Okay, which is plus I. Plus I and minus I will get 0. Okay. Let's solve this. I raised to 107 plus I raised to 112 plus I raised to 117 plus I raised to 122. So same way you have to solve. 107 you can write it as 106 into I. This is already even, so you can take divide by 2, 56. Okay. 117 you can write 116 into I, and 122 you can divide by 2, 61. Okay. So 106 divided by 2, 53. So minus 1 raised to 53 odd. So this is minus I. What about this? This is positive. 1. Okay, because this is minus 1 raised to 56. 116 divided by 2, 58. So, which is an even number, minus 1 raised to even number, positive I. What about this? Odd number. So, this is minus 1. Okay. So, this is also 0. Next one. You have to prove that 1 plus I raised to 10 plus I raised to 100 minus I raised to 1000 is equal to 0. Okay, you have to prove this. So starting with LHS, 1 plus I raised to 10, you can write it as I square raised to 5 plus I raised to 100, you can write it as I square raised to 50 minus this is I square raised to 500. Okay. So I square is minus 1, minus 1 raised to 5 is minus 1. This is positive and this is also positive. So minus 1. This is 0, which is our RHS. Okay. So these are some examples of how to convert that I. Okay, so some more examples. See, to prove that I raised to 17 minus 1 upon I raised to 34 square is equal to 2i. Okay. Starting with LHS, this is I raised to 17, so we can write 16 into I minus 1 upon I raised to 34. So this is 1 upon I raised to 34. So we can write this as 17 2s are 34. So I square is to 70 square. I raised to 16 is I square raised to 8. So this is a positive number I. What about this? Minus 1 raised to 70. So minus 1. So this becomes plus 1 square. So use a plus b the whole square formula. I square plus 2ab plus b square. I square is minus 1. So the final answer is 2i. Okay. So easily you can solve this type of problems. There is one more concept in this, that is this we have to prove. Okay. Root of this, root a into root b, is not equal to root of a into b. Okay. So here we have to prove this, that is by using some example. Okay. So if I take say a equal to, this doesn't apply for a complex number, that is with a negative sign. A and b, if they have a negative sign, then this doesn't apply. So let's start. If let's say this number is a is our minus 2, okay, and b is minus 3. So starting with LHS, root a into root b. So root of minus 2 into root of minus 3. Root of minus 2, I can write it as root of minus 1, okay, into 2 into root of minus 1 into 3. Okay. Further, we can write this as root of minus 1 into root of 2 into root of minus 1 into 3. Now, this minus root of minus 1 is nothing but I, right? And this is also I. Okay, we have to take the numbers which has a root. Say I'll take this as 4 and this as 9. Okay. So this we can write it as 2 and 3. Okay. So I square into 6. So this is minus 6. LHS is minus 6. What about RHS? Minus into minus plus. So this is root 36, which is 6. Now this is plus 6 and this is minus 6. So RHS and LHS are not equal. Okay. This applies only for the numbers with a negative sign. Okay. Under root, the numbers should be negative. Now there are some examples on this also. So if you have, say, root of minus 25 into root of minus 81. So how to compute this? Root of minus 25, you can write minus 1 into 25, and this is root of minus 1 into root of 81. Okay, so this is root minus 1 into root minus 1 into 5 into 9. So root minus 1 is our I square. This is minus 45. Okay, root of minus 36 into root 16. Now one has a negative sign, one has a positive sign. So this we can write root of minus 1 into root 36 into root 16. So this is I, this is 6, this is 4, this is 24I. Okay. Next one, 4 root minus 4 plus 5 root minus 9 minus 3 root minus 16. Okay. So this we can write root of minus 1 into root 4, which is 2, root minus 1 into root 9, which is 3, minus 3 root minus 1, 16 is 4. Okay. So this is 8I, 15I, 12I. Okay. 8 plus 15 minus 12, 3I, 8I. 8 plus 3, 11I. Okay. So now let's start with what is a complex number. Okay. A number of the form x plus iy or a plus ib. Okay. So it is given by z equal to x plus iy. Okay. This is a complex number. This part is called real part and this part is called an imaginary part. Okay, where I is root of minus 1 and x and y are real numbers. Okay, this is a complex number, and complex number like real numbers have a symbol like this. Complex numbers have a symbol C. Okay, so this is real part and that is imaginary part. Imaginary part contains only y, not I. Okay, I we don't include. Only y is our imaginary part. So real part is denoted by real part of z and this is imaginary part of z. So this is x and this is y. Okay. So two complex numbers are said to be equal if and only if their imaginary as well as real parts are equal. So two complex numbers say x1 plus iy1 is equal to x2 plus iy2 if and only if real parts are equal and imaginary parts are equal. Okay, let's start with some examples. So you have to write real and imaginary part of the complex numbers. So complex number is given. Okay, so this is of the form x plus iy. So real part is 7 and imaginary part is minus 3. Okay, so you have to include minus sign also. Now this number you have to write in terms of x plus iy. So this you can write 5 plus 0 into I. Okay, so here real part is 5 and imaginary part is 0. Okay, what about this? Again you have to write it in terms of x plus iy. So 0 plus 2i, real part is 0 and imaginary part is 2. This you have to solve. I square is minus 1. So minus 1 plus 1 it becomes 0. So this is nothing but 0 plus 0i. Okay. So real part is 0 and imaginary part is also 0. What about this? This is minus I plus 6. So here real part is 6 and imaginary part is minus 1. Okay. Side is given I raised to minus 6i plus 8. Okay. First you have to solve this. Okay. I raised to 95 means I raised to 94 into I minus 6i plus 8. So this is 94 divided by 2, 47. So I square raised to 47 odd number minus I minus 6i is minus 7i. So real part is 8 and an imaginary part is minus 7. Okay, let's solve this. So if you have this equation is given, you have to find x and y. Now you have to compare this with this side. This is given 0. So this you can write it as 0 plus 0i. Right. So this both the complex numbers are equal. And complex numbers are equal if and only if their real parts are equal and their imaginary parts are equal. Okay. So y is equal to minus 7 by 2 and x is equal to 1 upon 3. So this is x and y. Let's solve this. So here you have to find x and y if this is given. Now again you have to compare. Okay. So first you write this in the form x plus iy. So taking x terms together and y terms together. Okay. So you have to take imaginary parts together and real parts together. So this is 3x plus 5y plus 2y minus x I. Okay. Now you can compare. So comparing real parts, 3x plus 5y equal to 7 and 2y minus x equal to 5. Now these are linear equations in two variables. You can solve them by using elimination method. Okay, so I'll convert this into 3. So this is minus 3x plus 6y equal to 15. Okay, 3x plus 5y, 7. Eliminating, you will get y is equal to 2. What about x? x is minus 1. Okay.